Hello guys, welcome to this video. This is paper 047813 October November 2017. It's the same as 22110 October November 2017. So without wasting any further time, let's start. A washing machine has a small display screen built into it. One use of this is question number 1. Okay. One use of the display screen is to show an error code when a problem has occurred with the washing cycle. State whether the display screen is an input, output, or a storage device. So it's asking about the display screen. It's basically the monitor, and the display screen is used to show an error code. So when it is showing an error code, so it is obviously an output device. Okay, then the display screen shows a hexadecimal error code. This is the hexadecimal error code. Okay, this error code means that the water will not empty out of the washing machine. So now we have to convert this error code to binary. So the first simple step in converting from hexadecimal to binary is, first of all, that you have to take each digit. Like if 4 is on my right, okay, so I have to start 4 from here. I mean, these 4 binary digits will be secured for this 4. These 4 will be secured for the center number, which is 0. And for this, E is in hexadecimal, as I told before, A is 10, B is 11, C is 12, D is 13, and E is 14, and F is 15. Okay, so E is what? 14. So this side, the left side, because it's on the left, it's secured for 14. So you have to go in the same order in binary as well as the order that has been given in hexadecimal. So then the second step is that you have to put the place values 1, 2, 4, 8. Okay, for only 4 bits of binary for 4. Okay, then the same for this 1, 2, 4, 8 and 1, 2, 4, 8. This is not denary, otherwise that would be another case. Okay, so now you have to convert this error code to binary. Okay, so 4 is simply given here. This would be 1 and these all would be 0. Then 0 means all are 0, and this 14 means that 8 plus 4 is 12 and 12 plus 2 is 14. Okay, then part C says, state why hexadecimal is used to display the error code. Hexadecimal. Now you see, this was something in hexadecimal in which you have only 3 digits, and here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a 12 and this is 3. There is a vast difference between 12 and 3. So it means that the memory needs to store 12 digits here, and here the memory needs to store only 3 digits. So this is more effective for in terms of memory, you can say. So it takes up less storage space, less memory in the computer. So hexadecimal is used to display the error code because and one reason could be also this, that if, just imagine there's an error in your washing machine and the error message is displayed using this thing, and you're like, what is this? And you just take out a book and you match all those binaries, so it becomes difficult. So this is more easier to fit on this small screen display because it's a small screen display. It's already, this is a hint. So on that small screen display, how will this fit? Okay, so you can so they're saying only one reason because it's a 1 mark question, so you can simply write that it takes up less memory. Okay, now it takes up less memory in the computer. Okay, it takes up less memory. Okay, fine. 1 mark question, so this is fine. You can get a mark for this. Okay, then identify 3 sensors that could be used in the washing machine. So we all know that at first thought, we can just sense that it's basically number 1, it could be temperature sensor. Okay, so temperature, what would the temperature sensor do? It would basically just monitor the correct temperature of water for what you can say, for washing your clothes probably. So okay, let's write temperature. What kind of limit? Temperature of, okay, temperature of water inside the machine. Okay, then the second sensor that you can use could be pressure sensor, because I mean that could actually just tell you about like how much clothes you should put in, or how much water, you can say the level of water in the washing machine could be, you know, kind of monitored. Okay, and what about the third sensor? Okay, let's write about the second one first. So it could be this, just make space, be the, what did I say? Yeah, and one could be pH sensor as well. I'll tell you why. Okay, first you can write pressure sensor, or even it could be motion sensor as well, but I usually don't write them like pressure sensor here and then motion sensor here, because I don't know that maybe they would have given like pressure slash motion, so I would lose 2 marks here. So try to, you know, write a different sensor. So pressure sensor, it would monitor the level of, okay, monitor the level of water in the washing machine. It would monitor that either the, you know, water is too much or too less for, you know, clothes to be washed, so it would be good. And then pH sensor, if you are a chemistry student, then you can obviously sense it, because in the washing machine, when you're washing your clothes, there's a detergent that is placed into it, right? So that detergent actually needs what, it has somewhat pH. Okay, so the pH sensor will just monitor the water of the level of detergent present in the water. Okay, so let's see that if it is, you know, not in the required value when, so it can be used, I guess. Yes, so it can be used to monitor the level of detergent present, because detergent has a certain pH value, right? So then it can monitor that either the detergent is enough for the clothes or not. Okay, so this is fine. Okay, this question is done. Now we have question number 2. Data files are stored in different file formats. Okay, file formats, this is also one of the chapters in your O-level computer science book. Okay, complete a table by producing a suitable file format for each file type. The first one has been done for you. So when they do the first one for you, then it becomes quite easier for us to, you know, acknowledge it. So text, how which file format is your text file stored? Your most commonly used, like nowadays in your online classes, you see this thing .pdf. Okay, it's although it's also like this .docs or docs or .doc, like this. So you can write either of them. I'm writing .pdf, it's the most common one. Okay, sound is in MP3. Yes, sound is basically in MP3, because when you are you're downloading something. Okay, so a song, take an example. I downloaded, like if you're downloading a song or you're downloading anything, so like related to sound. Okay, it can be a song. Okay, so it's basically in MP3. Okay, MP3 file format. There are other file formats, but these are in your book, so just remember them. And then video, it's MP4. We have learned in our book that this one is MP4. Then this part is also very important. We often ignore it. This thing, it's also in our computer science book, but we ignore it often. So this is very important to remember that what three parts that make up this URL. This is URL, Uniform Resource Locator. You should also know its full form, which is Uniform Resource Locator. In one paper, you can also get this, and then you may lose 1 mark, and 1 mark really matters. So 3 parts that make up this URL are, so part 1 is HTTP. HTTP is one of the protocol used. Okay, so it's the protocol used. You can write protocol. Okay. And then this one is file name, index.htm. Okay, this one is file name, and this one is the domain name. Okay, protocol, domain name, and file name. Just remember the 2 of the things, any 2 of here, and then you can exactly remember what the third one is. So the most easier for me to remember is that HTTP is a protocol. I know that. So this is always the protocol, and this one is the file name, and so obviously this one is going to be the domain name. Okay, after www dot, there is a domain name. Good. Then now what is meant? Okay, this was the start of question number 3. So this is part B of question number 3. Describe what is meant by an internet protocol IP address. Okay, so what is an internet protocol IP address? It's basically what we have learned so far. It's a unique identification okay, unique identification address. Okay, MAC address is basically unique identification code of a device connected on internet. IP address is basically the it is used to identify the device on the internet. Okay, it is used to identify the device on the internet. It is not a code, it just identifies that a certain device is connected on internet. Okay, so IP address is used to identify a device, okay, on internet, connected to the internet, and it is allocated by or assigned by, okay, it is assigned by the internet service provider. Okay, your internet must have an IP address as well. It would be given to, like, if you have PTCL or if you have Zong, so they must have been given it. That's the internet service provider, right? So it uska bhi, you will have an IP address. Okay, it is assigned by the internet service provider. Then you can say that IP address. Yeah, one more thing that you need to remember. This is a 4-mark question, so you actually need 4 points, and you need to drive down into your memory lane and see that what did you study about the IP address. So IP address is used to identify a device on internet. It is assigned by the internet service provider. Then IP address can also be used instead of URL. Okay, can be used instead of URL, because if you go to the address bar and write an IP address of a website, it will also give you that. Okay, so even if you're not writing the URL, so it can be done. Okay, then one more thing that the 4th point, that IP address can be static or dynamic. Okay, so can be static or dynamic means that it can be static. It means that it doesn't change each time it is connected to the internet. Okay, or it can be dynamic, that IP address can change maybe each time when a device is connected to the internet. Okay, so you can see that these are 4 points, that IP address is used to identify a device on internet. Okay, then IP address is like the street. Okay, it is used to identify a device, and MAC address is basically the code, the house number. Okay, then it is assigned by the internet service provider. IP address can be used instead of URL. You try typing the IP address of a website, you can get it, and you can do it. You can try it yourself. IP address can be static or dynamic. Okay, I hope this is clear. And this is question number 4. 6 components of a computer system and 6 descriptions are shown. Draw a line to match each component with the most suitable description. Okay, so you have to draw a line to match each component with the most suitable description. So these are very easy questions, and you can easily get this 5 marks from here. Okay, arithmetic logic unit. Used to connect together internal component. Okay, we'll see description. In the last paper which I did, I also used to see the description, and I don't see the components. I see the description first and then match it with the required component. It becomes easier that way. Used to connect together the internal components of the CPU. So it's basically ALU, no. This is no. Control unit, yes. Control unit actually used to connect together the internal components of the CPU. Yes, it is, because it is controlling, you can see it like this. It is controlling. It is used to connect together the internal components of the CPU. It is controlling those components and they're connecting together. Okay, it's controlling. So you can see that. Used to carry out calculations of data. So this is basically arithmetic. Arithmetic is the calculation stuff. So obviously it would be, what do we call it? Arithmetic logic unit. Then used to temporarily hold data and instructions during processing. This is, no, it's not bus. It's register. These are registered. No. This is not register. Wait, it's let me think. It can be either immediate access store or it can be either register. Okay, but it's actually the register. Okay, there's 2 main things that are different in this. This statement says that used to temporarily hold data and instructions during processing, and this says that used to hold data and instruction before they are processed. So it's quite clear that during processing, registers are used to temporarily hold data and instructions, okay, during processing. So it's registered. Then, and this one used to hold data and instructions before they are processed. So this is immediate access store. Okay, you can just immediately access it from there. Okay, and then it's where it is, yes, used to allow interaction with the computer. This is quite simple. It's not buses, it is input output, because we interact with the computer through monitors, through keyboard, through touch screens, which is actually the input and output device. So used to allow interaction within the computer. And buses, it's used to manage the flow of data through the CPU. So 1 2 3 4 5 6. Okay, done. We're done with this question. Then draw a logic circuit for the logic statement. Okay, this is the logic statement given. We have to draw a logic circuit. Okay, x is 1 if a is 1. Now make sure the brackets, be careful about these brackets. Okay, this is one bracket and then there's another bracket. Okay, and it's okay, I'm not writing it here because it may take space up here. Let's write it here. So here bracket, then another bracket. A is 1, which means we want to do anything to A, and B is 1. N means dot and B is 1. Okay, or is plus. A is not 1. Not 1 means it is bar. Okay, and C is 1, and then again this. So you have two logic statements which are being or. Okay, A is 1 and B is 1, so we just did A dot B, and then or A is not 1, which means it's bar not. It's like a cross. Okay, you can see it's A is not 1. You could also say like this. This is not 1. This is not, sorry, this A, and you cross it out. But no, in computers it's bar. Okay, so it's A dot B plus A bar dot C. So let's draw it. I'll draw it with a pencil. Okay, I have to leave some space for A as well. I'll draw A bar first, the inverter gate, and I'll leave some space for here. Okay, so very neatly I have to draw it. Try to be as neat as possible. NOT gate is the only one gate which actually has only one input. Otherwise all your gates have minimum of 2 inputs. Okay, maximum of 2 inputs. So this is A dot B bar. First let's dot it. A dot B bar. Where is B? Sorry, A dot B only. Okay, this dot means AND gate. Make sure you memorize what are gates clearly. A dot B bar. Okay, and sorry, A dot B, and then plus A bar dot C. So A bar is now from here. This is A bar. Not like up till here it's A, and then from here it's A bar, and then you have they've given us quite sufficient space for this. Okay, from where I have to go? Wait. Okay, I have to go from. Let me just. Because this needs to be AND with this, right? Let me just. Okay, I'll go through here, and then I would just make a pathway for. Okay, wait. Okay, wait. I'm going to do this like this. Like this. Okay. And then these two are going to be alright. So let me do it from here. Let it be out from here. From here. Oh no, it needs to join here. Wait, I need my eraser. Where it is. I always lose erasers during paper solving. Okay, fine. Here it is, this tiny eraser. Okay, this one. No, it should pass from the middle. So I'm trying to get it through, but you know, you have to, I don't know if it's necessary, but try to do so if they're expecting you to, you know, end the gate over here. So just now let's pass it through the center. Okay, now the center, and to this one, which I had a long, you know, route, you could always do this like this. No, not this. Just a minute. it means that this one is passing from here. Okay, so you don't need to do it like this. This one is passing from here and this one passes from here. So now this is accurate enough. Okay, then this needs to be a bar dot c and this needs to be here. Okay, so you can make that OR gate. Okay, you bring it a bit of here, a bit of here. This is quite of your logic. Okay, you have to apply logic because it itself is a logic gate. Okay, now I can see that you have to play through this these types of question. So now you can cross check a dot b, then this is plus with a bar dot c. Okay, so this is done. Now okay, we don't have a truth table over here. Fair enough. So next is this was question number 5. This is question number 5b. Draw the symbol for an XOR gate and explain the function of this logic gate. So what is an XOR gate? So the symbol you need to know. This is the symbol. Okay, make it till here only, like this. Okay, because it's going like this. Okay, like these wires should be attached with this and this should be above it. The mistake I did was basically, and you don't need this, this is needed for a connection, but you don't have a connection right now. It's just a gate. Just draw it like this, just a gate at the moment. It's not used in a circuit. The mistake I did was this. I used to make it like this and this. Where is the attachment? Where is the wire attaching? So then I have to attach from this and this. Okay, fine. Now leave this. So this is the symbol for the XOR gate, and what is its explanation? So we have to explain the function of this logic gate. So the function, it is similar to an OR gate. You can see an OR gate is this. This is your OR. We just drew it. This is OR, and then you have just like this. So it is similar. It is, you have 5 marks for this. 1 mark is probably for this drawing. It is similar to an OR gate. Okay, and then you can write that it takes in 2 inputs, like all logic gates. Okay, so this point can also be credited. It takes in at least 2 inputs, and then you can write, Acha, I have a thumb rule for this XOR gate. It has this symbol, right? XOR. So whenever I see this symbol, which is XOR gate, I have a thumb rule for it, which is if there are same values, same 0, opposite 1. So same value is 0, opposite is 1. So I have a thumb rule for it. For example, let me draw a little tiny truth table. Okay, 0 0 1 1 0 1 0 1. Okay, so let's do it now. Let's A XOR B. Let's do it. Yes, I'll tell you. Same 0, so it's same values are 0. Yes, these are opposite values, right? This is 0 and this is given an like in terms of high and low, this is given a high and this is low. So this is opposite 1, same 0. This is same, right? 1 and 1 is same. So opposite is 1. This is a key rule because I often get confused in high low, but this is a key rule, that same 0 opposite 1. But I can't write it over here because this is my theory, okay? This is not stated in the book. It's like it is stated in a different manner, okay? But I learn in that case, like, which I can easily remember. So from that remembrance I can write that it is similar to an OR gate. It takes in at least 2 inputs, okay? It gives an output of 1, okay? It gives an output of 1 if both, you see, output of 1 is what? This is the output, right? Output of 1 if both inputs are different, right? Inputs are not same. Here the input is same. So I can write that using my knowledge that it gives an output of 1 if both inputs are different. Then it gives, I can also explain another scenario, an output of 0 if both, when is the output of 0? If both inputs are same, okay? If both inputs are same, that is both 0, okay? Both are 0 or both are 1, okay? So this, I think I can get marked for it. It is similar to an OR gate. It takes in at least 2 inputs. It gives an output of 1 if both inputs are different. You can always draw a truth table for your convenience. It gives an output of 0 if both inputs are same. That is both 0 or both are 1. So this is done. Now, this is one statement, 2, 3, 4. Okay, fine. Describe the operation. This is question number 6 of a 2D scanner and a 3D scanner. Okay, so we have 2D and 3D. These are 6 marks, so we need to apply at least 3 points for each. So 2D scanner. This was a huge, colorful process listed on the book. Okay, so first of all, in a 2D scanner, light is shined onto the surface. Light shines on the surface of document. Okay, scanner light on the surface of document, or you can say that a bright light illuminates the document. Okay, then light is reflected back, okay, using lenses and mirrors. Okay, and then the captured image, the image that is captured by the reflected light is converted into a digital file, and then a 2D digital image is produced. So we can write in that case that in 2D scanner, a bright light illuminates the document. Okay, then light is reflected back, is captured. Okay, first of all, bright light, you shine a bright light, the scanner shines a bright light, okay, illuminates the document, and then the light reflected back is captured. Okay, light is reflected back, okay, and it is captured. When it is captured, then it uses mirrors, using mirrors and lenses. Okay, because light, when it is reflected back, it is captured using mirrors and lenses. Mirrors and lenses are used in reflection and processes. It is some physics stuff. Okay, So a bright light illuminates the document. A light reflected back is captured using mirrors and lenses. Then captured image is eventually converted into a digital file, you can say. Okay, so this is what a bright light illuminates the document. Light reflected back is captured using mirrors and lenses. Okay, and then captured image is eventually converted into a digital file. Then for a 3D scanner, 3D means three-dimensional scanner, and this means two-dimensional scanner. Two-dimensional scanner always scans the x and y coordinates of the image of the document, and this actually scans x, y, and z coordinates. Okay, but you don't need to tell the features, you need to tell the operation. Okay, how does it do that? How does it scans the x, y, and z coordinates? Okay, so in a 3D scanner also, the scanner shines light onto the surface of the 3D object that needs to be scanned. Okay, and then what happens that the dimensions of the object are recorded. Okay, and then measurements are then converted into a digital file, and that eventually produces a 3D digital model. So you can say that scanner shines light onto the object. Okay, shines light onto the surface of object to be scanned. Okay, a scanner shines light onto the surface of the object to be a surface of it's basically a 3D object using a 3D scanner. Okay, so it is a 3D object to be scanned, and then it eventually records. Okay, it then records the dimensions, which I told, that x, y, and z coordinates. Okay, it records the measurements of the dimensions of the object. Dimensions, the spelling is S. Dimensions of the object. Okay, and then when the measurements are recorded, then these measurements are eventually converted to, because it is a scanner input device, so it is converted analog. Input device takes an analog data and converts it to digital, right? So now this analog measurements, okay, these measurements are converted to a digital file, and this is enough for 3 marks. Okay, because obviously in every scanner the light is shown, okay, first, and then measurements are recorded of the x and y, y coordinates. Okay, and x, y, and z coordinates, or the dimensions of the object, you can say, and these measurements are converted into a digital file. Okay, now this is question number 7. 6 statements about firewalls are shown. Tick to show whether each statement is true or false. Okay, let's see. Firewalls can monitor incoming and outgoing traffic. Yes, it is true. Then firewalls operate by checking traffic against a set of rules. Yes, because you can see that we have learned that it sets a criteria for traffic, and okay, so against a set of rules. Okay, then firewall cannot block access to a certain website. It cannot block access to a certain website. No, it can does if it's not safe for you. Can be software and hardware, yes. Act as intermediary servers, no, these are proxy servers. They act as intermediary servers. And then can block unauthorized traffic, yes, it is true. Firewalls can block unauthorized traffic. This is actually proxy server. Fair enough. Now question number 8. Data is valuable. Yes, data is extremely valuable. It needs to be kept secure and it can be easily be damaged. Describe 3 ways that data can be accidentally damaged. Okay, accidentally damaged, it says. So let's see how it can be accidentally damaged. Just think for a moment. It can be accidental deletion of data, which is actually a human error. Okay, accidental deletion of data, human error. For example, if you are selecting pictures, okay, or you're selecting some files to delete and move to the pen, and you accidentally select the file that you don't want to delete and it deletes, because so that's an accidental deletion of data. That's a human error. Okay, then it can be also due to a power failure, and the file wasn't safe. Okay, so power failure while working on a document, and the file wasn't saved. You didn't save the file, so the work was finished. If your computer was connected to power and you didn't, that's why everyone says that you have to keep saving your work again and again. Okay, power failure while working on a document that has not been saved. Okay, or power failure can also result in other stuff as well. Okay, and then it could be any hardware or software fault. So you can say that it can be hardware failure, hardware fault. Okay, maybe your computer crashed, something happened like that. Okay, maybe there wasn't enough storage and things became worse. So hardware fault could be another thing, or software fault. Okay, then the secure sockets layer protocol can be used to securely transmit data in online banking. Describe 3 other different applications that use SSL. Online banking is already there, so you can say online shopping. It can also be used in your emails. Okay, securely transmitting data can be in online shopping, emails, and also in your the most common thing, video conferencing, which is common during these COVID times. So conferencing. Okay, then part C,